Hi everyone, today we are going to continue with the motion chapter part 2. We'll look at some important questions and problem solving techniques on speed, distance, time and acceleration. So what are the tips here whenever you are solving the numerical in physics? First, read the question carefully, list the given data, check if any unit conversion is required like centimeter, meter, kilometer. All the data supposed to be in same units as you are aware of. Apply the correct formula, substitute and simplify, give the answer with the correct unit. So unit also most important in physics numerical whenever you are solving. Let us look at the first question. An object has moved through a distance. Can it have zero displacement? If yes, support your answer with an example. In our earlier video, we have learned distance and displacement differentiation. From that, we are very sure that an object can cover certain distance, but it can have zero displacement. Yes, that is possible. We have already learned about it. If you look at the example 1, when a person walks along a straight line from point P to point Q and comes back. Suppose if the person has started from point P here, he is moving forward and coming back from point Q to point P. That means he has covered a distance of 6 meter and displacement is 0 meter because his initial and final points are same. Coming to another example, if a cyclist covers 2 rounds about a circular park of radius 500 meter, it can be any number of rounds, but it has to be a full round. N number of rounds we can say. So in this scenario, if the person has started from point A in anti-clockwise direction, let us say, or clockwise direction, whatever, if the person has started this way and he reached again point A after one round, so he is covering a distance of about the circumference of the circle. So we all know the circumference of the circle formula 2 pi r. As per the question, the cyclist is covering 2 rounds about the circular park. So the distance covered must be 2 pi r times 2 because number of rounds are 2. So it would be 4 pi r. Substitute the value of radius of the park given, which is 500 meter, 4 pi into 500 meter. You may further simplify this by considering pi value as 3.14 or you may leave as 200 pi meter. Displacement, again, as he is starting from point A, reaching the point A back after completing each round, the total displacement is 0 meter. So these two examples will justify the statement given in the question. Now the second question. A farmer moves along the boundary of a square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds? That is the question given. So if you look at the question, it is very clearly evident the field is in the shape of square. So let us draw a small diagram to understand the question, whose side is 10 meter. So we all are aware of each side is same in square, so 10 meter, and also the data is saying the data given is, so look at the question here, square of side 10 meter, he is covering one full round in 40 seconds. That means 40 meter, nothing but the perimeter of the square, which is 10 plus 10 plus 10 plus 10. Suppose if you assume this point is A, B, C and D. Here the farmer is starting and completing one round 40 meter he is covering in 40 seconds. That is what mentioned in the question. So it is clearly evident 40 meters in 40 seconds means we can easily say 1 meter in 1 second. The question is, what will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds? So 2 minutes 20 seconds, that means distance we need to know. So first we will take time is 2 minutes 20 seconds, nothing but 140 seconds. 2 minutes 120 plus 20, 140 seconds. So it is clearly evident the distance covered by the farmer in 140 seconds would be 140 meter. Distance covered in 140 seconds is equal to 140 seconds into 1 meter in each second. So that will come 140 meter. Now we know how much distance the farmer has covered. Okay, let us take how many rounds he is actually completing. This is the distance, not the displacement. Therefore, number of rounds would be total distance covered 140 meter by each round he is covering 40 meter. So if you take this calculation 40 meter, we will get 3.5 rounds. That means he is covering 3.5 rounds in 2 minutes 20 seconds. That means the person will be at, if A is the starting point, the person after one round 1, 2, 3 and half round. That means he is exactly at the opposite corner of the square, which is A to C. C is the opposite corner of A here. So the displacement would be AC. Displacement is equal to AC, which can be easily calculated by using the Pythagoras rule. Hypotenuse square AC square is equal to side square plus side square, which is AB square plus BC square. That can be obtained 10 square plus 10 square, which is 100 plus 100, 200 meter square. 200 meter. Then you will get AC is equal to under root 200, that can be given by 10 root 2 meter. So you can say the answer as 10 root 2 meter, or as we are aware of the root 2 value 1.414, you can also take this 10 into 1.414, that would give us 14.14 meter. This is how we solve this entire problem. And in the question they asked only about the magnitude of the displacement. They didn't ask about direction. In case they ask about the direction, you can say 14.14 meter from A to C, because C is the final point and A is the initial point. So the farmer is moving along the diagonal 14.14 meter from A to C. Third question, which of the following is true for displacement? It cannot be 0 and its magnitude is greater than the distance traveled by the object. So these 2 points also covered under distance and displacement differentiation. So it's easy for us to figure out. Both the statements are false. Here they are asking which of the following is true for displacement. Even they are saying displacement cannot be 0. Displacement can be 0, as we have seen in the previous question. Question number 1, it is very clearly evident when the person has started from point P to point Q, and if he comes back, so P to Q, Q to P, that means his displacement is getting 0, but that question is saying it cannot be 0, which is false. Similarly, the second part of the question, its magnitude is greater than the distance traveled by the object, which is also false, because you can see here the triangle. If a person has started from point A to point B and he reached to point C, okay, A to B, B to C, he has reached. So A is the starting point and C is the ending point for the person. Distance covered would be 4 meter plus 3 meter, that would come 7 meter as per the total length of the path. Whereas displacement, again if you apply the Pythagoras rule, we are able to get side square plus side square is equal to 3 square plus 4 square, which is 9 plus 16 under root 25. So and root of 25 is nothing but 5 meter we will get as the displacement. And look here, the displacement we got is 5 meter, which is not greater than 7 meters. So displacement is always either less than or equal to displacement. So this example will clarify that question. Coming to fourth question, during an experiment, a signal from a spaceship reached the ground station in 5 minutes. What was the distance of the spaceship from the ground station? That is the question given, and they have given the value of speed of light. The signal travels at the speed of light, which is 3 into 10 power 8 meter per second. So as per the question, let us write the data given. We have to estimate the distance. So distance is question mark. What else has been given? The speed given, which is v into 3 into 10 power 8 meter per second, and the time also given, which is 5 minutes. So if you check the data, time is in 5 minutes. So we'll convert that into seconds, which is 5 into 60, 300 seconds. So now apply the right formula. Distance is equal to speed into time. We all know this formula. So speed is 3 into 10 power 8 into time is 300 seconds. That would give us 900 into 10 power 8 meter, or we can write in the full scientific form by taking these two zeros as 10 power 2 and add the 10 power 2 to 10 power 8, like 9 into 10 power 2 into 10 power 8. We all know that when the bases are same, powers can be added. So 9 into 10 power 10 meter is the answer for the distance in this question. Coming to question number 5. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. As I mentioned earlier, let us take the data given clearly. The speed is decreasing from 80 km per hour to 60 km per hour. That means initial speed is u, which is 80 km per hour, and final speed is v, small v, which is 60 km per hour. The time given is in seconds. The question mark is for acceleration. How to find acceleration? Let us recall the formula for acceleration, which is change in velocity, which is v minus u upon time. So if you look at the data here, speed is in kilometer per hour, time is in second. So we are supposed to convert the time into hour. So it is easy for us to convert kilometer per hour into meter per second. But the thing is, instead of converting u and v 2 times, what I am going to do here in a simple way, v is 60, u is 80. So 60 minus 80 whole divided by time is 5 seconds into, I am converting this kilometer per hour into meter per second by multiplying with 5 by 18. So we can do the question in a simple way. 5 can be cancelled, 60 minus 80 minus 20 upon 18. You can further simplify this by using two table. Negative 10 by 9. You will get minus 1.11 meter per second square. If you notice, we got the acceleration value negative. That means this is nothing but retardation. So you can say acceleration is negative here, or in case the question is asking for retardation, when we are using the word retardation, you are not supposed to use negative sign. Directly you can write 1.11 meter per second square. But the question is asking for acceleration, so you can mention the answer with negative sign. A is equal to minus 1.11 meter per second square. Next question 6. A train starting from a railway station and moving with uniform acceleration attains a speed 40 km per hour in 10 minutes. Find its acceleration. That is the question. So let us write the data given under the solution. So the data given was initial speed has not mentioned. So let us assume that the train is starting from rest. From a railway station means we can consider the initial velocity of the train is 0 km per hour. And it attains a speed of 40 km per hour, which is V, 40 km per hour, with a uniform acceleration, which is a small a, which we doesn't know. We have to find that. The time interval given is 10 minutes. So again we are going to convert that time into seconds. 10 into 60, which can give us 600 seconds. Apply the relevant formula for acceleration, which is change in velocity, v minus u by t. That will give you v is 40, u is 0. Again you might wonder, kilometer per hour. I am converting here again like in the previous question to make the calculation easier. Time is again 600 seconds. So if you see this and further simplify, 40 minus 0, 40 into 5, 200 we will get, divided by 600 into 1 by 18. So 200 can cut here 3 times. The answer will come around 1 by 54 meter per second square. You may leave the answer in like this, 1 by 54, or you can also give the answer in decimal place up to 1 or maximum 2 decimal places by dividing this. So 0 point, then it will become 10. If I put one more 0, it becomes 100. So 54 only we can cancel by one time, 54, and then 46 will remain and it will become 460. That will go up to 8 times meter per second square. Even you get more decimal places, we usually take up to 2 or 3 decimal places maximum. This is how we can calculate the acceleration in the given question. There are certain questions given for you to try on your own using the relevant formula. Please try on your own and we'll discuss these answers in the next video. Thank you all.